Okay, let's take a look at application of some of these principles that you've learned in chapter 4. We're going to do that by looking at problem 56. So the first thing that I've done here is I've uh, labeled this tab 4.56, and here are the questions that it's asking. Now I've totaled up the rows here, and I've totaled up the columns here. Okay, so basically what we have here is that we can say in total 100 out of 800 houses sold uh, were sold in under 30 days. 500 were sold in 31 to 90 days, and 200 it took over 90 days to sell them. And then as far as sales price is concerned, 100 of the homes sold for less than 150,000. 250 of the homes sold for this range. 400 of the homes sold for this range, and 50 of the homes sold for a price greater than 250,000. Now we want to know some things. We want to be able to predict some things that are going to happen, so we'll know when we list a house, for instance, how long it will probably take to sell the house. Do we know how long it will take? No, it's unknown. So we can guess. We can just make a wild guess, or we can make a guess based on past data. So let's take a look at this. First, we're going to ask ourselves, what's the probability that A, which is the listing period, is greater than 90 days? Well, all of these houses, it took more than 90 days to sell. So 200 out of the 800. So we could calculate the probability just by saying, what is 200 divided by 800? And we get a probability of 0.250. So the answer to A is just simply the probability that it'll take over 90 days based on past experiences is about 25%. So the answer is just 0.250. Okay? Now, what's the probability that B, which is the price for which the house was listed, is under $150,000? Well, 100 of the 800 were listed for that amount, so I can calculate the probability. This divided by the total is 1.25. Okay, so the answer to that question is the probability that the house will be listed for less than $150,000 is about 12.5%. Okay, simple, simple. All right, now C says, what's the probability of both A is greater than 90 and B is less than $150,000? Well, all I have to do is find out where those two things intersect. So here's the row, 150,000. Here's the column over 90 days, and this number right there, 10 out of 800 were listed for less than $150,000 and took over 90 days to sell. So what is that? That just equals 10 divided by the total is a fairly small probability. So the answer there is equals this, because it's both under $150,000 and over 90 days to sell. So it's right there. Okay? All right, now, D is the hardest part of this. D is conditional probability. It says, okay, given that the house listed for $150,000, what's the probability that it will take longer than 90 days to sell? Well, in order to do that, I can look at the formula and I just take the probability of both happening, which is what I just calculated, the probability of both things happening, divided by the probability of the independent variable happening. Okay, so we'll say that the house was listed for $150,000. That's independent. How long it's going to take to sell would logic would tell you that might be dependent on what the price was. So I'm going to divide it by the probability of the independent variable, which is the part that was given. Okay? I'm going to add some decimal places here just to keep things equal, and it's roughly 10%. Then it says, are A and B independent? So is the listing period and the sales price, are they independent of each other? Well, all I have to do is I look at what's the overall probability that's going to take 90 days, greater than 90 days to sell a house, and it's 25%. But if I list the house for 150%, then $150,000. I'm sorry. If I list the house for less than $150,000, then the chances that it will take greater than 90 days go down to 10%. So are A and B independent? No. We can say that the listing duration is dependent to some degree on the sales price. So the answer is no, they are not independent. And then I'll just put that over there and I'll save it. Okay, and there we go. If you can do that, you should be able to do your homework.